All right, so solving linear equations, rules for solving linear equations. First, you want to isolate the variable. 2, undo operations with their opposite operation. So undo PEMDAS, right? And then third, always do the same thing to both sides of the equation. Those are the rules that we follow. Okay, so we talked about how, let me pause JT over here. We talked about some of the procedures and how they work. So when it's written as 3 equals x with the reflexive property, I can reflect that, right? And it can become x equals 3. Simplifying, before you do anything, you want to simplify both sides of the equation. And then remember, the inverse of adding is subtracting and vice versa. So to move across, you're going to do that. Multiplying. Multiplying, the inverse of multiplying is dividing and vice versa. So then after you've added and subtracted across the equal sign, then you can multiply and divide across the equal sign. And then you can do your exponents, okay? So goal here, solving linear equations. Here you have a simple linear equations, ax plus b equals 0, okay? This is our traditional, pretty straightforward 2-step linear equation, okay? Sometimes linear equations are called first degree equations, and that's because the power of your exponent is the power of your variable is a 1. Right here is Casper, the friendly 1, okay? And so that's why the degree, sometimes it's called a first degree equation, okay? You'll hear that more often when we get to our polynomial unit, but for right now, we can stick to calling it a linear. All right, so let's go through solving this first linear equation. So we have 5 times x minus 2 equals 3 times x minus 1. So the first thing we want to do is to eliminate parentheses. So we want to eliminate parentheses. And how I'm going to eliminate parentheses? I'm going to distribute, right? Distribute the 5, distribute the 3. That's going to leave me with 5x minus 10 equals 3x minus 3. Okay, still with me? Step 2, for the sake of simplicity, my step 2 is always move the variable to the left, okay? It doesn't matter whether you move the constant or the variable, but for the sake of simplicity, I encourage you to move variable terms to the left. So in this case, I want to move the 3x. In order to move a positive 3x, I'm going to subtract. And what I do to one side of the equal sign, I do to the other side. I simplify and I'm left with 2x minus 10 equals -3. Notice how the minus 3 stays with the 3. Okay, the operation stays with the number. My step 3 is going to be to move the constant. Again, step 2 and step 3 are interchangeable. But for the sake of notes and simplicity, I'm just going to stick to what I just told you. So we're going to move the constant. So constant terms to the right. Constant. I think I spelled that wrong. Yep, there we go. So we're going to move the constant terms to the right. So my constant term is -10. Notice how I included the operation with the number. So how do I move a -10? I'm going to add 10. Simplify, and I'm left with 2x equals 7. My next step is to either multiply or divide because I need to isolate the variable. So I need to isolate the variable. So in this case, what do I need to do to get x by itself? Divide. And what I do to one side, I do to the other. So we end up with x equals 7/2 or x equals 3 1/2. Okay, this is a single solution, a unique equation, right? Does all of this sound familiar? Yes, you know that I didn't make it up, right? Cool. So it'll be all worked out for you. So if you were to do this graphically, I forgot I had the graph on the other side. If you were to do this graphically, again, we are not equal to 0, right? So we would be looking for the intersection, okay? All right, so I'm going to talk about this one. What do you notice we have to do here? FOIL, good old FOIL. So for this problem, we're going to have to FOIL, which is just a fancy way of saying distribute multiple times, right? So it's just the process of distributing multiple times. So for this problem, we have to simplify the left and right side first is our step. So simplify left and right. And that's so that we can eliminate the what? Parentheses. Okay. So following our FOIL, FOIL tells us we multiply the first terms together. So we get 2x times x is 2x squared. Then we're going to multiply our outside terms together. So 2x times -1 is -2x. Then we're going to multiply our inside terms together. So we have -1x. Then we're going to multiply our last two terms together. So we have -1 times -1 is +1. Drop my x. So I can simplify this down to 2x squared minus 3x plus 1. I'm going to repeat the same process on the right-hand side. So we have x times 2x gives us 2x squared. And then we have x times -5 gives us -5x. We have -5 times 2x gives us -10x. And we have -5 times -5 gives us +25. We're going to simplify this and we get 2x squared minus 15x plus 25. Okay. When an equation has the same term on both sides, that term can be eliminated. So notice here I have 2x squared and I have 2x squared. That term can already be eliminated. Do you see how that works? All right. Step 2 is now we're going to start moving. So we want to move our variable terms. So I'm going to move -15x. How would I move -15x? I'm going to add 15x. Make sure you're bringing your variable along with you. That leaves me with 12x plus 1 equals 25. Our third step is to move our constant term. My constant is 1, a +1. So I'm going to subtract 1 from both sides. I'm going to simplify, and I'm left with 12x equals 24. Our last and final step is to isolate the variable. What do I need to do to isolate the variable? Divide. So we divide and we get x equals 2. Okay. So we have x equals 2 is our solution. Now, if this was on your graphing part of your test, you would be able to graph by putting in y1, your left side, y2, your right side, and finding their point of intersection. How do you feel? Good? Awesome sauce. I keep forgetting that I have the line thing. I just keep going like a crazy person. All right, rational equations. Yay. So I'm gonna cut it here.